Okay, today we're going to look at study guide 3. So we start off with a long jumper leaves the ground at an angle of 23 degrees above the horizontal at a speed of 11 meters per second. The height of the jumpers can be modeled by, by f of x equals negative 0.046x squared plus 0.363x, where f of x is the jumper's height in meters and x is the horizontal distance from the point of launch. So we're looking at a shape like that, a parabola. At what horizontal distance from the point of launch does the maximum height occur? Round to 2 decimal places. So we are looking for the vertex. I want to know this distance for part A, which would be the x value. So recall that x is simply negative b over 2a. So in this case, that's negative 0.363 over 2 times negative 0.046, which gives us negative 0.363 over negative 0.092. Negative divided by negative is a positive, and rounded to 2 decimal places is 3.95 meters. Okay, now we want to know what is the maximum height of the long jumper, and again rounding to 2 decimal places. So in this case, we're looking for f of 3.95, which is negative 0.046 times 3.95 squared plus 0.363 times 3.95. So we're looking at negative 0.6241 plus 1.43385. And we add them, we get 0.81 meters. Okay, number 2, we simply want to find the vertex of the following equation. We just did that. So we're looking at negative b over 2a. Negative 5 over 2 times 2 equals negative 5/4. F of negative 5/4 equal to 2 times negative 5/4 squared plus 5 times negative 5/4 plus 3. So I'm looking at 25 over 16 times 2, which is 25 over 8. Here I'm negative 5 times negative 5 is negative 25. So I have negative 25/4, which would be negative 50 over 8. And 3 is simply 24 over 8. So I have 25 minus 50 plus 24, which is negative 1/9. Or 1/8, I'm sorry, negative 1/8. So our point is negative 5/4, negative 1/8. That is our vertex. Okay, next we want to find the zeros. So looking at this, look at two at a time. See what happens. I can factor out from these first two x squared, which gives me x squared times x plus 6. And here I can factor out -5, which gives me -5 times x plus 6. And I want to know when this is going to equal 0. So I have x squared minus 5 times x plus 6 equals 0. So either x squared minus 5 equals 0 or x plus 6 equals 0. Well, if x squared minus 5 equals 0, x squared equals 5, and x equals plus or minus the square root of 5. Likewise, if x plus 6 equals 0, then x equals -6. So my zeros are square root of 5, negative square root of 5, -6. Okay, identify the vertical, horizontal, or slant asymptotes. Write none if there are none. So vertical, we just set the denominator equal to 0. X equals 0. Now, the degree of the numerator is 2. The degree of the denominator is an understood 1. That means we do not have a horizontal asymptote. Okay? However, since the degree of the numerator is 1 greater than the degree of the denominator, we may have a slant asymptote. So we bring out our long division, fill in the x term. Not that we're going to need it here, because I have 3x times x gives me 3x squared. Subtracting, I get 0. I bring down this 2, doesn't matter. My slant asymptote is y equals 3x. It's always the linear part. You don't have to worry about the remainder. Sketch the function. So there are multiple ways we can do this. It is a parabola, and unfortunately, it's a little bit off the graph. But that's okay. We can work with this. How about we do this? We just make these 2, 4, 6, 8, and 10. 2, 4, 6, 8, and 10. -2, -4, -6, -8, -10. 2, 4, 6, 8, 10. That way it'll fit. So we have a parabola. -b over 2a. b is -5, so the negative of -5 is 5 over 2. So b is 5/2. Or the x coordinate is 5/2. And then we have f of 5/2 equals 5/2 squared minus 5 times 5/2. So this is 25 over 4. And this is minus 25 over 2. So this is 25 over 4 minus 50 over 4, or -25 over 4, which is 6.25. This is 2.5. So a little beyond 2 and a little beyond 6, right about there. That is our vertex. 2.5, 6.25. Then we need to find some points. So if we set this equal to 0, I have 0 equals x squared minus 5. So 0 minus 5x. So I have x times x minus 5 equals 0. So x equals 0 or x equals 5. So 5, 0, 0, 0. Then we know it's a parabola, so we're good. It just says sketch it. It doesn't say it has to be perfect. Okay, now we have another function to graph here. So first we need to consider what our asymptotes are. Well, for vertical, we have x equals 0, which is right here. And for a slant asymptote, this one's relatively easy because we don't have horizontal. 2 is greater than 1, so no horizontal. But 2 is 1 greater than 1, so we have a slant. We take x into x squared plus 0x plus 2, and that's simply x. Gives us x squared. When we subtract, we get 0, bringing down that 2 again, which doesn't matter. So this is simply y equals x, which is basically this. So we can plot some points. What happens when we have f of 1? I get 1 plus 2 over 1, which is 3. What about f of negative 1? Well, that's 1 plus 2 over negative 1, which is negative 3. So it looks like we have some symmetry. So let's look at this. We can put this in our calculator. Y equals, open parentheses, x squared plus 2 divided by x. And graph it. And you're going to get a shape something like this. So that's what we're looking at. Again, I'm looking general shape. I'm not looking precise. Okay, next, solve using the substitution method. And again, this is a case of me pulling numbers out of my rear end, and it doesn't come out pretty. So let's go ahead and let's solve for x in the first equation. So I have 2x equals 3y plus 2. X equals 3 halves y plus 1. Now we can plug that in here. And I have 3x plus 2 times 3 halves y. Nope, got it backwards. 3 times 3 halves y plus 1 plus 2y equals negative 7. So this is 9 halves y plus 3 plus, what, 4 halves y? 2 is 4 halves. Negative 7. So I have 13 halves y equals negative 10. Multiplying both sides by 2 over 13, I get negative 20 over 13. Okay? So now I take this and plug it in here, and I have x equals 3 halves times negative 20 over 13 plus 1, which is 13 over 13. So what I have here is negative 60 over 26 plus 13 over 13, which is negative 30 over 13 plus 13 over 13, which gives me negative 17 over 13. So my point is negative 17 over 13, negative 20 over 13. If memory serves me correct, the test question will come out a little better. Okay, now we're going to solve using elimination. So what can we do here? What if I multiply the first equation by negative 2? I get negative 2y, or negative 2x plus 4y equals negative 8. Move over the other equation, 2x plus 3y equals negative 6. Add them together and I have 0 plus 7y, that's a 0, equals negative 14. So y equals negative 2. Then I plug it in and I get negative 2 minus 2. Yep. Come on, computer. There it goes. So I have x minus 2 times negative 2 equals 4. X plus 4 equals 4. X equals 0. So my point would be 0, negative 2. Now, since these numbers are pretty, we'll go ahead and test it. 0 plus 4 equals 4, yes. 0 plus negative 6 equals negative 6. So this is our solution. Okay, now we're going to graph the solution set of a system of inequalities. Then we'll start with x minus y is greater than 0. First thing we do is note it's strictly greater than, so we're having a dotted line. Go ahead and change it. And basically we have x equals y. So if x is 0, y is 0. If x is 1, y is 1. If x is negative 1, y is negative 1. So essentially I'm looking at this. Now the problem is my 0, 0 is on that line. So, well, why can't we just put a point, a test point of 1, 0? That's right here. So is 1 minus 0 greater than 0? It is. So we're shading this side of that line. All right, I'm going to change to a different color if it'll let me. And let's go blue. So now we look at x plus 2y is less than negative 2. Again, x plus 2y equals negative 2. Find us some points to define our line. If x is 0, y is negative 1. If x is 2, y is negative 2. And if x is negative 2, y is positive 1. So I have 0, negative 1. I have 2, negative 2. I have -2, -1, and again, strictly less than dotted line. Two, -2, and this is here. And we're dotting this line here. This time I can test 0, 0. So with 0 plus 0 less than -2, it is not. So that means I'm shading the underside. And then my solution is this part in here. Okay, last one. Graph the solution set of the system of inequalities. So we'll start with 2x plus y is less than 1. Again, it's strictly less than, so dotted line, 2x plus y equals 1. When x is 0, y is 1. When x is 1, y is -1. When x is -1, y is 3. So we're looking at 0, 1, 1, -1, -1, 3. And again, we draw our dotted line. Technically, 0, 0 is not on the line, so we can test it. Test 0, 0. Have 0 plus 0 is less than 1, which is true. So I'm shading the under or left side, depending on how you look at it. Now let's go back to red. And we're looking at x plus 2y less than 5. Again, dotted. I should have put some solid lines in here, but I didn't. X plus 2y equals 5. I'm going to start with x equals 1. Because that gives me 2y equals 4, so y equals 2. How about x equals -1? Now that's -1, adding 1, 6, 2y equals 6. We have 3. And let's go ahead and say 3. We get -1. No, +1. So we have our 0.12, -1, 3, and 3, 1. And we have a dotted line here. And again, we can test 0, 0. We get 0 plus 0 less than 5. Check. So we're doing this section below. And then our solution is in here. And that, I believe, is it.